Hello everyone, welcome back to MathLAB programming course. Today I'm going to show you how we can calculate the transpose of a matrix, which is very important. There are a lot of areas where we need to find a transpose of a matrix in order to get the result. So let me show you how we can do that in MathLAB. Exactly like vectors, when we had a vector, let me create one. Here we do have a 1/5 vector, and I showed to you that if you wanted to calculate the transpose of a vector, the only thing we need to do is to put a single quotation exactly after the name of the vector. And if we do that, we can come up with a 1/5 vector. The same holds true with matrices. So let me clear the screen. I put A equals 1, 2, 3, 4, 5, 6, 7, 8, and 9, 10, 11, and 12. So now I do have a 3/4 matrix, right? So if I calculate the size of A, it's going to be 3/4. Now, if I want to create the inverse, what I need to do is put, let me call it B also. So what I need to do is to put A transpose, right? I put B, a new matrix, which is the transpose of A. And if I do that, you see that we create a 4/3 matrix. So size of B is now 4/3. Therefore, exactly like vectors, the way to calculate the transpose of a matrix is through employing single quotation. Let me clear that. Another important feature we need to learn is, let me create a square matrix. I'm just trying to create a, let me make it different. So, okay, I think it's okay. Now I created a square matrix which is 4/4. Sometimes we need to extract the diagonal elements of a matrix like this: 1, 6, 5, and 2. So I'm only interested on the diagonal elements. The way that I can do that is through a function called diagonal. So diagonal of matrix A simply calculates only the elements on the diagonal. So we could easily extract that. And if you need it in a 1/4 vector, what you can do is to put ends like that and calculate it. It's always better when you extract a part of a matrix, you make a name for it. So for example, it would be better if I put D equals diagonal of A. So now I can put the transpose. So it's easy to calculate the diagonal elements, and they're very important, especially in some areas like control engineering, because it enables us to calculate the eigenvectors, eigenvalues, and other important features. Okay, so let me clear that to start the next item. There are a lot of times when we need to just extract a portion of a matrix. Let me bring A here. Okay. So what if I need only the upper part? So if you look at it, it's a square, and I can divide it imaginarily by just drawing a line on the diagonal to make it upper and a lower division, right? So if I draw a line on the diagonal elements, they're going to be divided into upper and lower. What if I was interested into extracting the upper part of a matrix? How can I do that? If I cut the upper part or the down part of this matrix into half, it's going to be a triangle. So I can use a function triangle, and now I need to specify whether it's upper part or the below part which I'm interested. Now let's go to upper part. And if I do that and pass A to it, you see that the new matrix which is created is all the elements below the diagonal element the diagonal line is going to be 0, and the upper part is only left. So it's like that. We only extract the upper part of this matrix and put everything else into 0. We do have a very similar option on lower elements of the diagonal. So let me do this. We can extract the lower part by try low and pass the matrix. So if I do that, now you see all the upper parts are assigned to 0 and the lower part is left. If I want to give you an example where we use these, we all had numerical analysis courses where you were asked to find the values for 3 variables numerically. And later in project section, I'm going to use all these features and show you how useful they are in programming field. So today we'll learn how to extract the diagonal elements, the triangular upper part, the triangular lower part of a matrix, and also the important function of transpose. Please keep in mind that you need to practice all these functions in order to instill the MATLAB programming skill. So far, you've done a great job, and I will see you in next video.